research projects I'm working on is to try to figure out which one of those possibilities it is.
Is that a water ice surface, or is that a rock surface?
It's water ice. Yep, water ice with a little bit of dust mixed in. But I'm going to go to one of these really small satellites here, and this is one that's become very exciting recently. A satellite that almost nobody knew about before a few years ago, called Enceladus. It's actually one of the brightest, intrinsically brightest objects in the solar system. It's all white, and it's all made of very small grains of water ice on the surface. So it's like completely covered. It's as if it was completely covered in newly fallen snow. And again, when we got close to it, this is a Voyager picture from 1980. We knew from Voyager that it had this ancient surface with craters on it, but then it had these recent fractures cutting across. Sounds familiar, right? It's just like a lot of the other Saturn satellites. This satellite is really tiny, though. If I go back to this other slide here, you notice this is one of the smallest Saturn satellites. In fact, this thing is only about 500 kilometers from one side to the other, which is not a very large body. So how could you possibly have enough internal activity in a body like this to rip the surface apart? Well, it turns out it's even more interesting than that. Huh?
As with Mercury, it was resurfaced recently.
Yeah, well, even more recently than Mercury, as you'll see in just a minute. So here's just a size comparison of Enceladus, just to show you just how small it is. There's Great Britain for scale. Could easily plop into the North Sea, and nobody would miss it.
How many Rhode Island?
Yeah, yeah. Well, a bunch of Rhode Islands, unfortunately. Well, let's see, how many? 10 or 15. As we've started zooming into the surface and to see how the surface has been modified, you see these sort of ancient impact craters on the surface. It kind of looks like these soft craters like you find on the lunar highlands of our moon. But then they have all these cracks going across it, all these deep chasms cutting them apart. It seems to have happened recently. Here's another picture looking at part of Enceladus' surface where it's clearly been all ripped apart.
It looks like things like fun sledding or something on a hillside.
Yeah. It's a big hillside. Yeah, exactly. And you notice these...
How deep do they calculate those skiing?
Oh, how deep are these things?
Yeah.
Several hundred meters to a kilometer deep. Yeah. So, not quite like Grand Canyon scale, but still, bigger than anything in concrete.
Now, is that, it's solid, or is it powder, or are they just flat ice?
Yeah, well, that's a good question. As I said, the color of the surface and the reflective properties of the surface are just like newly fallen snow. So it seems to be a very powdery ice surface. But along these cliff faces, they've found things that look much more like the sort of blue, solid glacier ice below that. So it may be sort of like very solid ice interior that's covered with this ice powder on top.
It's a great place to go skiing.
It'd be an awesome place to go skiing. In fact, this place is so small, it's about 1/100th Earth gravity. So yeah, you can. First of all, you wouldn't be going very fast, but if you did hit a jump, you could really, do
But there aren't any heavy.
Raised portion? The left side of the picture, is that a raised portion?
Oh yeah. Most of these are troughs going down into the surface. Down here, there's actually some ridges sticking up above the surface, and those have completely mystified everybody so far. But there isn't how those could have formed. So.
But there isn't enough height to go skiing on.
Yeah.
Gravity problem.
Kilometer. Yeah, with gravity 1/100th, you wouldn't.
Well,
You'd probably want to have some kind of jetpack to get yourself going fast enough. Here was the big surprise, though. It came from an instrument on Cassini that measures temperatures in the infrared. Kind of like an infrared thermometer, like you might use. Here's what we predicted to find when they looked at Enceladus. This is the view that they had. Here's the south pole of Enceladus. They expected that it would be warm where the sun was overhead right here, and then it would be cold around that. By warm, I mean about 80 Kelvin, which is 200 below Celsius. But this is what they observed instead. Something funny going on. There's this big warm spot on the South Pole. By warm, it's like 85 Kelvin, but that's much higher than the predicted 65 or 70 Kelvin that they expected. And when you translate that into how much power you would need to heat that large of a region of Enceladus, it takes several gigawatts of power to do this. So something is happening to heat up just the South Pole of Enceladus and nothing else.
Not the North Pole.
Not the North Pole, nothing seems to be going on, just the South Pole. Strange, huh?
You're making this.
Here's a picture of the South Pole. It has all these cracks going across it. And when they did detailed temperature scans across it, they found that these cracks, in fact, were much warmer than their surroundings. So somehow there's these cracks opening up and there's a lot of heat coming out from the interior. This got even more exciting when they took a picture looking back toward the sun with a thin crescent, Enceladus, and there are these geysers of water mist spraying out into space from the South Pole of Enceladus.
Carbon dioxide, it's water.
Yes, it's almost all water that's coming out of here. So the water is spraying out of the surface in these huge geysers. And these geysers, actually, they've taken farther away pictures to try to get a better view of this. And these geysers are bigger than the moon itself. I mean, they go way off into space. Of course, gravity is so low, you don't have to launch something very fast to get it to go way out there. Yeah.
So in other words, it's kind of snowing out in space around there, which might explain why some of the moons are covered in snow.
Mm-hmm. Yeah, and in fact, if you're standing there on the surface, it would sort of look like a snowstorm coming out of the ground. Just be all this ice dust just shooting out of these cracks off into space. Although these are so tenuous that it wouldn't be like a heavy snowstorm. It would just be sort of a fine mist.
A snow volcano.
Yeah, it is kind of like a snow volcano. So somebody asked, you were asking about volcanoes. Turns out there's actually snow volcanoes.
Well, I was thinking
the
that
Saturn
there was a
system.
volcano like in Jupiter, a lot of its ring. Not Jupiter, it was a Saturn, a lot of the ring material came from volcanic activity on the moons. So I was thinking a lot of the material came from volcanoes and snowy stuff on it.
Right. So like around Jupiter, it has the most volcanically active body in the solar system is Io, the innermost moon of Jupiter. And those volcanoes are going off so much it leaves this huge ring of sulfur around Jupiter. And it turns out Enceladus does the same thing. There's actually a ring of water ice dust around Saturn that follows Enceladus' orbit. Yeah.
How far is Enceladus from Saturn? Distance?
I don't know the absolute distance. It's the second major moon out. It's quite a ways out past the rings. It's like maybe about, if you think the distance from Saturn to the rings, you have to go about that, or to the end of the rings, you have to go about that far again to get out to Enceladus.
But still close enough that maybe Saturn is enacted some sort of tidal.
Yes.
Perhaps?
Yeah. And that's the idea, is that maybe this has to do with some kind of tides and tidal heating. Although why it's happening to Enceladus and not to the one that's even closer to Saturn, Mimas, which is cold and dead and nothing's happening there, is a big
Has some
question.
sort of internal radiation?
It's one possibility that it might be more rocky, and so you might have more radiogenic heating, but it's so small that it's hard to keep heat in this tiny little body. I mean, it's going to cool off very fast. So these geysers are shooting about 150 to 350 kilograms per second of material out into space. And it's not only water, it's almost all water, but there's also carbon dioxide, nitrogen, and this is where it gets interesting, methane, I think this is acetylene, ethane, other kinds of simple organic compounds are also being shot out of Enceladus. So there's some kind of interesting organic chemistry that's also going on inside Enceladus.